All right, so this is the continuation of Chapter 7, Section 2 for FOM 11. Last lesson we ended off with sort of being able to recognize what the values of A, B, and C do to the graph. We talked about A having the ability to open it up or open down. B also does sort of some shifting of up and down of what the vertex is. And it sort of makes things move left or right depending on if this is a plus or minus. Plus C, or the constant, depending on how big negative this is, it will shift the graph down. If it's positive, it'll shift the graph up. Okay? And one new idea is this thing called the axis of symmetry. An axis of symmetry is some imaginary line that goes literally through the lowest point on the graph. And in the last lesson, we called the lowest point on the graph called the vertex. And now we're going to call it the minimum. So the lowest point is the minimum, and the highest point is a maximum. So the axis of symmetry goes through the vertex. Okay? So let's take a look at example number 1. It says here a time-lapse picture of volleyball in the air taken every 0.25 seconds. The height of the ball are given in the chart. So at time 0, it's 2 feet. So my first coordinate point's there. 0.25, it is 0.25 here. It's 6 feet high. And then at 0.5, it's 8 feet. And 0.75, it's also 8. At 1 second, it's down to 6. And at 1.25 seconds, it's at 2. So when does the volleyball reach its maximum height? So if you were to sort of, again, I apologize for my handwriting, but if you were to sketch it, hopefully you would know that it reaches its maximum what looks like somewhere in between. Oops! My handwriting is like really, really bad, okay? So it reaches a maximum somewhere in between here. Somewhere between 0.5 and 0.75. So we're going to call the maximum here. We don't know what the maximum is, but hopefully you would agree it's definitely slightly higher than 8. But the maximum occurs at the axis of symmetry. Okay, and when is the axis of symmetry? Meaning what time is it? Well, it's going to be somewhere between 0.5 and 0.75. So I'm going to add 0.75 plus 0.5, and then I'm just going to cut it in half because it's going to be right in the middle. So it's going to be 1.25 divided by 2. So it's going to be 0.6. You know what? I better not guess. Just use a calculator here. So it's going to be 1.25 divided by 2. So 0.625 seconds. Okay. Question number 2 says, water jets spray out of the ground. The path of water can be defined by this function, negative 0.12 x squared plus 3x. So as soon as you see the square, you know that it's going to be some sort of parabola. Okay, where x represents the horizontal distance in feet from the jet, and f of x represents the height. So this will be height, and this is the distance away from where the water is pouring out. So sketch the graph of the path of the water. Now, of course, one of the ways we can do it is we could do like a little t-table where we go x, that's the distance away from the jet, and f of x, which is just the height. Okay? But what we're going to do is we're going to save a little time, and I'm going to jump on decimals. So here we go. We can go y, right? Instead of f of x, we can go y equals negative 0.12 x, and I need the keyboard to put the square plus, oops, plus 3x. Oh, okay, so here's my graph. So this is sort of like, you can imagine watering your lawn or whatever with a hose. The water spouts up, it hits a maximum, and then it comes back down somewhere else, okay? So it says, what's the maximum height? Well, using Desmos, we can at least click literally right there. Okay, you find the maximum height. Desmos will be able to find it for you relatively easily. On your phone, you just tap the highest point, and it'll happen at what looks like 12.5 and 18.75. So how do you read that? Well, x is the distance away from the spout, so it's 12.5 meters away from the spout, and the height is the y value. So it says, what's the maximum height? Well, it's going to be 18.75. What's the correct unit? Oh, feet, right? The height is in feet. How far horizontally was it from the highest point? Oh, so based on, I'm going to bring my Desmos back up. Oh, it's 12.5 feet away from, okay, 12.5 feet away from the spout. And again, I apologize for my handwriting. It says, how far horizontally does the water travel before it hits the ground again? Well, if the maximum is at 12.5, that's the axis of symmetry, right? That's the axis of symmetry. So again, I'm going to bring up my Desmos. So it's 12.5 from 0 to here. That means it's going to be another 12.5, which is a combined total of 25 feet. It says here, what do you notice about the points on the parabola? For every point on one side of the axis of symmetry, you have one on the other. Absolutely. So if you sort of here, take a look one more time. Here's my axis of symmetry. I can't draw on Desmos, but you have corresponding points left and right, left and right, left and right. Okay? So for every height, there's 2 times. Here it was at 0 height. Well, again, it's going to be at 0 height on the other side as well. Here at 10 feet high, the water was 10 feet high on its way up. It's going to be 10 feet high on the way down. Okay? All right. Number 3 says, can you graph y equals x squared plus x minus 2 to state all the required information? Again, I'm going to use Desmos, and I suggest you as well. And so let me just shrink this page a little bit so we can have Desmos at the same time. All right, so let me just get rid of this graph. And it's going to be, my phone is going blink all over the place. I don't know why. I'm really not that popular. X squared plus x minus 2. Okay, so what I'm going to do is I'm going to try my best to sketch that, all right? So let me blow this graph up a little bit. The lowest point looks like -2, and I don't know, somewhere way over here, -2, and I don't know, somewhere down here. And then it looks like it crosses what looks like the x-axis at 1 and -2. 1 and -2. And so it sort of looks something like this. Okay? Now, what's the vertex? Well, you can just tap on your phone or your computer and it automatically tells you it's -0.5 and -2.25. So my vertex is going to be -0.5 and -2.25. Well, the axis of symmetry is super duper easy to read. It's just your x value at the vertex. Oh, so it's x equals -0.5. Done. Domain. What x values do you see? Well, if you tap any point on the graph, all you have to do is just read the x values. Now, I can't show you much more of this graph without losing a whole bunch of square footage on my screen, but you can sort of imagine it keeps going on and on and on to the left, and then you can imagine on the other side it keeps going on and on to the right. Well, that's all the x values, right? If you can imagine it went on forever. So we say domain, and the way we say it is D colon, that's the 2 dots, what looks like squiggly brackets, x. X is the set, okay? It looks like an E, but it says x is the set of everything. Well, how do you write everything? Well, you draw what looks like 2 parallel lines, and then what sort of looks like an R, and you close it up with squiggly brackets. Okay? So, domain, x is the set of all real numbers. Now, range. Well, that's y values. I'm going to do my squiggly brackets as well. Well, what y values do you see? Well, the lowest y value I see is negative 2.25. And if you tap any point, if the lowest value is negative 2.25 and everybody above it, how do you say everybody above 2.25? Oh, we say y, everybody's greater than negative 2.25. Okay? And again, I apologize for my handwriting. Is this a maximum or minimum? Oh, well, that's easy. It sort of bottoms out, right? So it's a minimum. If it bottoms out, it's a minimum. All right? Y-intercept. Oh, where does it cross the y-axis? Oh, y-intercept right there. So what you do is you relocate where it crosses the y-axis and you record that. My y-intercept is at x equals 0 and negative 2. All right. That's easy enough. What's the x-intercepts? Oh, negative 2, 0, and 1, 0. Okay? So that's easy enough. Desmos is super useful. All right, last example it says here, path of a skier's jump is described by the function y equals negative 4.9x squared plus 15x plus 1, where x is the time. This time, x represents time, and y represents height. Can you sketch the graph of the motion? All right, so I'm not going to sketch it, though you could. I'm just going to type this in as negative 4.9x squared plus 15x plus 1. And let me show you. Here we go. So I'm going to blow this up. Oh, it looks like at time 0. All right, at time 0, you can't have negative time, right? You can't go back in time as of yet. All right, at time 0, it looks like he's what looks like going off a jump or something. And then he goes up, up, up. He hits some sort of maximum, right? Just like a skier going off a jump would, and then eventually comes down to the ground. Okay, so I'm going to quickly draw this, and I'm going to probably do a really bad job, but all right, he goes up. I'm going to use these intervals as time, so it's 1, 2, and 3. So this is 3 seconds. He goes up, and then he eventually comes landing sometime after 3. So again, my drawing is going to be terrible compared to what Desmos can do. All right, so determine the skier's maximum height. Okay, that's super duper easy. On Desmos, all I do is I just tap the highest point, and it looks like the highest point is 12.48, whatever my units are. So my height is going to be 12.48. Don't forget, let's see, is it meters? Yep, it's in meters. So we're going to say height is 12.48 meters. Okay, normally we put boxes around the answers so your teacher can see what your answers are. Now, what's the range? Now, range is y values, right? So what are the y values you see here? Well, yeah, I guess you can imagine the skier eventually starts at 0, but he's starting here at 1-ish, around 1-ish, taking off the jump. He goes to a height of 12.48, and then he comes back down. And yeah, he does go negative, but hopefully he survives the jump and doesn't plow himself deep into the snow. We would say that he ends up at 0. So what is the range? Well, his range is the lowest value he can have, okay, colon. He has the lowest height of 0 meters, right? And what's his maximum height? Well, his maximum height is 12.48 meters. And range, if you have a minimum and maximum, you always put the minimum first, maximum last, and in this case, range is y. All right? If it was domain, you'd put x in the middle. If you had a lowest value of domain and highest value of domain, okay? And then don't forget to close the squiggly bracket. And that concludes this particular lesson.